Welcome to the question series of Strength of Materials. This is question number 4. A 200 mm long stress-free rod at a room temperature is held between two immovable rigid walls. The temperature of the rod is uniformly raised by 250 degrees Celsius. If the Young's modulus and coefficient of thermal expansion at 200 GPa and 1 into 10 to the power of minus 5 per degree Celsius respectively, this should be R. The magnitude of the longitudinal stress in megapascal developed in the rod is, so let me make the diagram. So there is a 200 mm long stress-free rod, and this is held between two immovable rigid rods. Okay. Now what is being asked is asking what is the magnitude of the longitudinal stress. So we know that in thermal problem, so sigma is given as the thermal stress is E alpha delta T. These are the direct formulas that you should be there in your tips. Okay, there is no time to construct or derive the formulas. You know very well in exam you don't have that much of time, so there are certain things that you need to mug it up. So sigma is equal to E epsilon delta T, where delta T is nothing but change in temperature. So here we are talking about increase in temperature, so increase in temperature will be delta T is 250 degrees Celsius. The value of E is given as 200 GPa, which means 10 to the power of 3 MPa, and the coefficient of thermal expansion, that is alpha, is given as 10 to the power of minus 5 per degree Celsius. Okay, so if you substitute that, you'd get the value sigma as 200 into 10 to the power of 3 into 10 to the power of minus 5 into 250, and this will come out to be 500 megapascal. So one add-on for this, if I ask you what is the nature of this stress, you will say that it is a compressive stress. Why? Because here they have mentioned that there is an increase in temperature, and if there is an increase in temperature, so this rod will try to get elongated, but due to these restrictions there will be a compressive stress generated inside this body. So the nature for this is compressive. So there will be a compressive stress which is generated inside this rod, which of the magnitude 500 MPa. Okay, see you in question number 5 in the next video. Till then, bye.